Energy. This is a word that we all use in our day-to-day life, and we hear it all the time. But if you ask someone to define the word energy, most of us would struggle to explain what it is. We know it's all around us, and we need it to power our electronics, all of our devices at home, and we know that we need it to move around, so we get it from food. But what exactly is energy? Well, I don't think that's as important of a question as understanding how energy behaves. So today we're going to focus on the law of conservation of energy, which tells us that energy cannot be created or destroyed. So if you can't create energy and you can't destroy it, what can energy do? And there's really just two major things. So number one, energy can transfer from object to object. So an example of this is if you're playing the game of pool and you hit the cue ball with your stick, that cue ball can roll and hit another ball, and then that ball starts to move. So that's an example of energy transfer. One ball giving its energy to another ball. The other thing that energy can do is it can transform from one type of energy to another type of energy. So an example of that is if you take a rock and throw it upward. It has kinetic energy because it's moving. That's the energy of motion. And as it climbs higher and higher into the air, that kinetic energy is turning into a new type of energy called gravitational potential energy, which is the energy of objects above the ground. So that's an example of energy transforming from kinetic to gravitational potential. And so energy all around us every single day is constantly transferring from object to object and transforming from one form of energy to another. So today we're going to look at several different physical setups, and I'm going to demonstrate all the different ways that energy can transform and transfer in our day-to-day lives. As I go through all the different energy stations during this video, I'm going to be pointing out 8 different forms of energy that you're going to see present in those demonstrations. And so I want to briefly explain all of them so that you know what I'm talking about when they come up. The first is called gravitational potential energy, which we abbreviate as GPE. And so gravitational potential is the type of energy associated with lifting objects above the ground. So if I take a rock and I lift it above my head, it has gravitational potential. It has the potential to start falling if I were to let it go. So anytime in these stations, if you see something rising up and gaining elevation, you know that gravitational potential energy is present. The second type is called chemical potential energy, which we abbreviate as CPE. And that's the type of energy stored in the chemical bonds within a substance. So we get chemical potential energy by eating food, and our body can metabolize that food and break it down. Chemical potential is also stored in batteries. So if you see batteries present in these stations, you know that chemical potential energy is at play. The third kind is called elastic potential energy, or EPE. And this is the type of energy associated with bending, stretching, or compressing a material. So when you do that, so let's say you have a spring and you pull it out and stretch it, you're storing elastic potential energy in that spring, and now it has the potential to snap back into its original position. So if you see any sort of bending, stretching, or compressing, you know that there's elastic potential energy at play. The fourth type of energy is kinetic energy, which we abbreviate as KE. And so this is the energy of moving objects. Any object that's in motion has kinetic energy. So in our stations in this video, if you see a moving object, you know that kinetic energy is present. The fifth kind of energy is basically just light, which we call electromagnetic radiation. So if you see anything emitting light, then you know that this energy is present. Number 6 is electricity, also known as electrical energy, and that's just the energy that's being transmitted as electrons pass through a wire. So if you see wires present and some device is working, chances are that electricity is involved. Number 7 is acoustic energy, also known as sound. So if you hear any sort of sound in today's demonstrations, you know that acoustic energy is being released. And last but not least, we have thermal energy, which is associated with heat. So if anything is emitting heat or getting hot, you know that thermal energy is present. Okay, so for our first station, we have this heat lamp here. I'm going to shine this light at a small solar panel that's hooked up via wires to this little speaker that's going to generate some sound. So I'm going to plug this wire in and let's see if this thing works. So that's pretty interesting, right? So what's going on with the energy here? Well, what is this light producing? Well, it's generating heat, so thermal energy, and it's also producing light. So thermal energy and light. The light travels to the solar panel, and the solar panel is converting that light into electricity. and it's sending that electricity through these wires, and then the speaker is converting that electrical energy into sound. So there's our first system, starting with light and heat, turning into electricity, and ultimately ending as sound. Okay, so here's our second station. It's a pretty simple setup. We have a pack of 2 batteries here. It's going to be hooked up via wires to this fan, and the fan's going to hopefully turn. So I'll go ahead and put the wire in, and there you have it. So what's going on with the energy here? Can you guys guess what kind of energy we started with, what it turned into, and what we ended up with ultimately? So take a moment, maybe pause the video and see if you can guess what kind of energy transformations are taking place here. Okay, so what we have is batteries. So that's chemical potential energy. That's being converted into electricity, which is flowing through these wires. And then there's a little motor here. So that motor is converting the electricity into the motion of this fan, and motion, of course, is kinetic energy. So we started with chemical potential energy, transformed into electrical energy, and ended ultimately with kinetic energy. Our third station is pretty similar to the last one, but instead of a battery pack, we have a hand crank that I'm going to turn, hooked up to wires connected to this fan. So I'll go ahead and do it, and then we'll break down the energy transformations. Here we go. And what's interesting is I had to crank that pretty fast in order to get this fan to turn. And that tells us just how much energy those batteries actually had in comparison, because the battery did it pretty effortlessly. So what did we start with? We have motion. So that means it's kinetic energy of our hand turning the crank. That's being converted again into electricity, which through this motor is being converted into the kinetic energy of these fan blades because they're moving. So again, we started with kinetic energy, became transformed into electricity, and ultimately transformed back into kinetic energy of another item. Our fourth station is just a battery pack hooked up via wires to a buzzer, which is going to produce sound. So before I even start this system, maybe pause the video and see if you can come up with the full explanation of what kind of energy we started with and how was it transforming throughout the system until the end. Okay, so I'll put it in here. And of course, that's the most annoying sound in the world. So how did it work? We have chemical potential energy stored in these batteries that's being converted into electrical energy running through these wires. And of course, that electricity is being converted into acoustic energy or sound via this speaker. For station number 5, we have a small solar panel hooked up with wires to this fan here. And I'm going to take my heat lamp and shine it directly at the solar panel, and the fan starts to turn. Notice that if I pull the heat lamp too far away, there's just not enough light to turn the fan, but if I get close enough, the energy is sufficient. So what's happening here with the energy? Maybe pause and write your response or think about it in your mind. Okay, so we have heat or thermal energy plus light being emitted by this light. The light is hitting the solar panel. It's being converted into electricity or electrical energy, and that electricity is powering this motor, which is turning this fan. And by the way, when the fan is turning, what kind of energy is that? That is, of course, kinetic energy. And for station number 6, we have a hand crank that's hooked up via wires to this buzzer here. So this time I'm going to try to make the buzzer make a sound with my hands. Here we go. And it looks like it worked. So what kind of energy did we start with? Kinetic, because we're moving the hand crank. That kinetic energy is transforming into electrical energy. That electricity goes through the wires and it transforms into acoustic energy, also known as sound. For station 7, we have a battery pack hooked up to a small light bulb. So when I plug this in, pause the video now if you want to try to think about it, but what kind of energy do I start with? What does it become? And what does it ultimately finish as? So here we go. And it's very simple, right? We have chemical potential energy stored in these batteries that's being transformed into electricity or electrical energy, which is passing through these wires. And that electrical energy is being converted into light or electromagnetic radiation. And for station 8, I have a solar panel hooked up to this light bulb here. I'm going to take this heat lamp and shine light at the solar panel. And so again, if you want to pause the video and take a guess as to what kind of energy transformation is taking place, go ahead and test yourself. So here we go. And so what's happening? We have light which is electromagnetic radiation that's being emitted by this lamp. It's also emitting heat as a byproduct. That light hits the solar panel. It's being converted into electricity, which travels through this wire and goes back to light again. So this is kind of a silly setup because we started with light and we just used this elaborate system to create light at the end. Okay, so this is my favorite station because what I'm going to do is just take these two metal spheres and I'm going to go ahead and crash them together at high speed. So here we go on 3, 2, 1. That seems very simple, right? So I just started over here, they're moving, and now they're not moving. So we started with what kind of energy? The spheres are moving, so that's kinetic energy, but then they stop moving. So if they're not moving anymore, they don't have kinetic energy, but energy can't just be destroyed. So what did that missing energy turn into? What did the kinetic energy become? Well, let's look at some clues to see if we can figure this out. So to get a better understanding of what the sphere's energies turned into after they collided, I'm going to smash them into this piece of paper here, and I'm going to do it several times so you can really clearly see what's going on. Take a look. So take a look at that. Do you see all those holes in the paper? Well, how could two round spheres create holes in a piece of paper? Well, I can tell you that from my point of view, I smell burning paper. So there was definitely heat present here. So that is evidence that the kinetic energy of these spheres transformed into thermal energy, and that thermal energy created enough heat to burn holes through this page. Wow. I don't know if I'm fully convinced. Kinetic energy to thermal energy, that sounds crazy. So I'm gonna need more evidence. What I'm going to do is put a thermal camera on my phone so that I can get infrared and actually see if we can detect the presence of heat using our infrared camera. Let's take a look. All right, so now I have an infrared camera pointing at this page. You can probably tell that my body is a lot hotter than my surrounding environment, which is normal. So what I'm going to try to do is get out of the frame and make sure you just see the two spheres coming in, and pay attention to the point of impact and see if you can see evidence that thermal energy or heat is present. Here we go. So it was somewhat difficult to see because of the interference in the thermal energy in the surrounding environment. But if you looked at the top of the screen, and you can go back and check, there's some little spots, some little hot spots that showed up right where those two spheres collided. So it is definitely evidence that the kinetic energy of the spheres transformed into thermal energy upon their impact. This is station number 12. You've probably seen this before. This is called a Newton's cradle. And basically I'm going to take this ball here, pull it all the way up, and then let it go. And you can see what happens. So how can we describe the energy transfer and transformations that are going on in this system? Well, when I lift this ball up in the air, what kind of energy am I giving it? This is called gravitational potential energy. When I let it go, I'll stop that for a second, it starts to move, and movement is associated with kinetic energy. So the gravitational potential becomes kinetic, but then this ball hits this one and the ball over here pops up. So what happened in between? This ball transferred its kinetic energy through all the other balls, and then that energy now is contained within this ball. So that was an energy transfer. That kinetic energy transforms into gravitational potential as this ball rises, and then starts to fall and becomes kinetic energy again, hits the other ball, transfers its kinetic energy through the other balls, and then now this one has it. And it just repeats back and forth over and over again. And last but certainly not least, we have station number 13. So I'm going to take this big fan and blow air at this fan, which is hooked up via wires to this buzzer, and see if we can get this buzzer to make a sound. If you want to pause the video now and think about all the energy present in the system, what do we start with, and what are all the transformations that take place from start to finish? This one does have quite a few steps, so see if you can come up with the answer. Okay, here we go. Let's do the demo first. There we go. And it looks like it works. Oh, for a little bit anyway. So what happened here? Well, this fan has a spinning blade. Actually, let's go further back. What is this fan plugged into? It's pulling electricity from the wall outlet. So we started with electrical energy. That electricity is transforming into kinetic energy as it turns this fan via the motor. So the fan's kinetic energy is pushing air from here to here. So now the fan blades are giving kinetic energy to the air. The air then turns these fan blades. So now the air's kinetic energy has been transferred to this fan. That kinetic energy is being turned into electricity with this little generator here. And that electricity is turning into sound or acoustic energy. So we started with electricity, then we had a spinning fan blade, so kinetic, then kinetic energy of air, kinetic energy of this fan blade, electricity, and ended at acoustic energy. Wow. And there we have it, 13 different stations to demonstrate how energy can be easily transformed or transferred from one object to another. And this happens every day, all the time throughout our day-to-day lives. So a more practical example might be your car. You use gasoline, which is chemical potential energy stored within that substance, and that is converted through your combustion process. There's a lot of thermal energy released, but ultimately that's turned into kinetic energy of your moving vehicle. So you started with chemical potential and ended up with kinetic and lost a bunch of energy as heat along the way. And that's the law of conservation of energy. Energy can always transform into new forms or transfer from one object to another, but it can never be created and it can never be destroyed.